फैक्टर होता है, वो कितने H पॉजिटिव आयन दे रहा है, वो उसका एन फैक्टर होता है। बेस का इक्विवेलेंट मास हम कैसे कैलकुलेट करते हैं, वो कितने OH नेगेटिव आयन दे रहा है, उसका एन फैक्टर होता है। सॉल्ट का एन फैक्टर होता है नेट पॉजिटिव चार्ज ऑन द कैटायन। इसके बाद एलिमेंट का एन फैक्टर होता है उसका वैलेंसी। और अगर हम बात करें ऑक्सीडाइजिंग और रिड्यूसिंग एजेंट का एन फैक्टर होता है द नंबर ऑफ इलेक्ट्रॉन गेन्ड और लॉस बाय द सब। तो मैंने लास्ट क्लास में आपको कुछ एग्जांपल भी दिए थे। जैसे मैंने ऑक्सीडाइजिंग और रिड्यूसिंग एजेंट के अंदर आपको एग्जांपल दिया था KMnO4 और K2Cr7, ये एग्जांपल मैंने आपको दिए थे। मैंने आपको इक्वेशन बताई थी, सामने आपके इक्वेशन है यहाँ पर KMnO4 वाली। मैंने इस इक्वेशन में आपको बताया था कि KMnO4 का एन फैक्टर कितना होता है, कितने इलेक्ट्रॉन वो गेन कर रहा है, बिकॉज इट इज अ गुड ऑक्सीडाइजिंग एजेंट। और एसिडिक मीडियम में हम लोग देखते हैं कि KMnO4 5 इलेक्ट्रॉन गेन कर रहा है। दैट्स व्हाई इट्स एन फैक्टर इज मोलर मास डिवाइडेड बाय 5। और साथ में मैंने कहा था कई बार बच्चे यहाँ पर 2 मोल्स देखते हैं और 2 मोल से वो कंफ्यूज हो जाते हैं कि यहाँ पर एन फैक्टर, यहाँ पर एन फैक्टर कहीं 10 तो नहीं हो जाएगा, m/10 तो नहीं हो जाएगा, और वो गलत कर देते हैं। आज मैं आपको ऐसा तरीका सिखाऊंगा जिससे कभी गलत होगा ही नहीं। कि फिर दोबारा आपको एक चीज मैं रिमाइंड करा दूंगा। देखिए हम लोग आप लोगों के लिए यहाँ पर मेहनत कर रहे हैं, चीजें आपको सिखा रहे हैं। उन चीजों को सीखने के लिए सबसे जरूरी चीज क्या होती है कि हम की प्रैक्टिस करें। और प्रैक्टिस करने के लिए जरूरी है कि हमारे पास कुछ ऐसा मटेरियल हो जहां से हम उसकी प्रैक्टिस करें। मैं यहाँ आपको बता दूं, आप समझ गए, ठीक है, लेकिन क्वेश्चंस कहाँ हैं? तो क्वेश्चंस का मैं आपको बता देता हूँ। क्वेश्चन बैंक है हमारे पास। वो क्वेश्चन बैंक का फिर दोबारा आपको एक बार मैं याद दिला दूं कि क्वेश्चन बैंक आपको मिलेगा कहां पर बेटा। ध्यान से बात को समझना। ये तो आपका शेड्यूल ऑफ क्लासेस, पिछली बार भी मैंने आपको बताया था, ये आपका शेड्यूल ऑफ क्लासेस है बेटा। ये लिंक से आपको पूरी क्लासेस का शेड्यूल मिल जाएगा, कब कौन सी क्लास शेड्यूल्ड है। जितने इंपॉर्टेंट फॉर्मूला है वो आपको यहाँ पर इस बुक के अंदर मिलेंगे, ई बुक में। तो जितने इंपॉर्टेंट फॉर्मूला है वो आप यहाँ से कर सकते हैं। केमिस्ट्री के लिए भी इंडिविजुअल है, तो सब्जेक्ट लिंक्स आपको मिल जाएंगे, जैसे फिजिक्स के लिए, केमिस्ट्री के लिए, मैथमेटिक्स के लिए आप हमारे इन लिंक्स को देख सकते हो। तो आपको यहाँ पर सब्जेक्ट के लिंक मिलेंगे जहां पर इंपॉर्टेंट फॉर्मूला आपको मिलेगा। इसी के अंदर देखिए, मैं क्योंकि केमिस्ट्री करा रहा हूँ तो केमिस्ट्री की आपको बुक ये साथ में बता रहा हूँ। इस बुक को भी आप लोग डाउनलोड कर सकते हैं। ई बुक है हमारे पास, इसके लिंक शेयर मैंने करे भी हुए हैं। आप लोग इस बुक के अंदर सेम फॉर्मूला जो मैं यहाँ बता रहा हूँ उसके ऊपर बेस्ड क्वेश्चंस बहुत सारे देख सकते हो, जिनको आप प्रैक्टिस कर सकते हो। तो आज हम लोग कॉन्सेप्ट को जरा आगे बढ़ाएंगे और सीखेंगे क्या होता है इक्विवेलेंट। मेरे बच्चों, जब मैं इक्विवेलेंट मास की बात करता हूं, और देखो हमने इतना सब कुछ सीखा, लेकिन ये क्वेश्चन ने हमें फंसा दिया था लास्ट क्लास में कि इस क्वेश्चन को हम कैसे करें। तो उन्होंने सिंपल हमें कहा कि एक मेटल है 10 grams ऑफ एन अननोन मेटल व्हेन बर्न्ड इन टू gave 14 grams ऑफ मेटल ऑक्साइड। व्हाट इज द इक्विवेलेंट मास ऑफ द मेटल? उस मेटल का इक्विवेलेंट मास क्या है जी, ये बताइए। हाँ, कैसे निकाले? अभी तक तो हमें मोलर मास भी नहीं बताया, मेटल का मोलर मास नहीं बताया, मेटल का एन फैक्टर भी हमें नहीं, हमें ये नहीं पता किस तरीके का ऑक्साइड है। अगर आप कॉन्सेप्ट को सही से समझोगे, आपको जरूरत भी नहीं है ऑक्साइड के फॉर्मूले की। कॉन्सेप्ट को सही से समझ रहे हैं, और इसके ऊपर क्वेश्चंस करवाऊंगा, बहुत बढ़िया बढ़िया सवाल है इसके ऊपर। तो सबसे पहले हम लोग देखें क्या होता है जी इक्विवेलेंट मास। इक्विवेलेंट मास थोड़ा सा अलग है बेटा। इक्विवेलेंट मास के अंदर वो चीज नहीं आती जो हम लोग, जैसे मोलैरिटी कोई आपसे पूछे तो मोलैरिटी आप बोलोगे इट इज द नंबर ऑफ मोल्स ऑफ अ सॉल्यूट दैट आर डिसॉल्व्ड इन एवरी 1 लीटर ऑफ सॉल्यूशन। मोलैरिटी में आप ये नहीं बोलोगे वेट ऑफ सॉल्यूट अपॉन मोलर मास ऑफ सॉल्यूट इनटू 1000 बाय वेट ऑफ सॉल्यूशन इन मिलीलीटर्स, ये तो फॉर्मूला हो गया। वैसे अगर कोई आपसे पूछता व्हाट इज इक्विवेलेंट मास, और इक्विवेलेंट मास के अंदर आप बोलते हो इट इज मोलर मास डिवाइडेड बाय एन फैक्टर, ये तो फॉर्मूला हो गया जी। इक्विवेलेंट मास है क्या, कैसे डिफाइन करें इक्विवेलेंट मास? इक्विवेलेंट मास को डिफाइन करने का कॉन्सेप्ट थोड़ा अलग है। नाम से ही पता चल रहा है इसका नाम क्यों है इक्विवेलेंट मास, बराबरी का मास, वो मास जो बराबर है। सो व्हाट इज इक्विवेलेंट मास? ध्यान से समझना, इक्विवेलेंट मास इज द मास ऑफ अ सब्सटेंस, को लिख भी लेना बेटा कहीं पर जो मैं बता रहा हूं। इक्विवेलेंट मास इज द मास ऑफ सब्सटेंस that reacts with that reacts with or displaces that reacts with or displaces 8 grams of oxygen or 1 gram of hydrogen or 35.5 grams of chlorine. तो व्हाट इज इक्विवेलेंट मास? किसी भी सब्सटेंस का वो मास जो रिएक्ट करता है या डिस्प्लेस करता है। इसको 8 ग्राम ऑक्सीजन को, 1 ग्राम हाइड्रोजन को या 35.5 ग्राम क्लोरीन, हम इक्विवेलेंट मास है। मैं यहाँ आपको प्रूव करके भी देता हूँ, जो हमने लास्ट क्लास में इक्विवेलेंट मास देखे थे तो हम लोग यहाँ पर प्रूव भी कर लेंगे, देख लेंगे। देखो जी, मैं सोडियम का एग्जांपल लेता हूँ। सोडियम, मैं अगर इसको क्लोरीन के साथ रिएक्ट करता हूँ Cl2 will give me 2 moles of NaC। मुझे यहाँ 2 सोडियम करना पड़ेगा बेटा। सोडियम का मोलर मास होता है 23, दैट इज 2 into 23 grams of sodium reacts with 71 grams of chlorine। क्लोरीन का मोलर मास 71 ग्राम क्लोरीन के साथ 2 into 23 ग्राम सोडियम रिएक्ट कर रहा है। तो 35.5 ग्राम क्लोरीन के साथ कितना रिएक्ट करेगा? 23 ग्राम। इसका इक्विवेलेंट मास। इसी तरह से मैं दूसरा एक एग्जांपल देता हूं और इसको प्रूव कर देंगे जो लास्ट क्लास में हमने पढ़ा था। मान लीजिए मेरे पास है कैल्शियम, Ca plus Cl2 gives you CaCl। ध्यान से देखना, 40 ग्राम मोलर मास है कैल्शियम का। संजय एक काम करें, आप मैसेज में मेरे को लिख दो अगर कोई आपका डाउट है तो। आई कैन नॉट मीन्स अनम्यूट यू, तो जो आपका डाउट है आप मैसेज में लिख दीजिए। ओके, try to bear with me because see some of the students they are from Hindi medium also, so I try to insert use both the languages.
Sir, please talk in English alone, sir.
Okay, I'll do that. Okay, so here we can see that 40 grams of calcium is reacting with 71 grams of chlorine. If 40 grams of calcium is reacting with 71 grams of chlorine, then how many grams of calcium will react with 35.5 grams of chlorine? The answer is 20 grams. This is the equivalent mass of calcium. Let's move a bit further. I've got another element, that is aluminum. If I react aluminum with chlorine, I will get AlCl3. AlCl3. That means 3 into 35.5 grams of chlorine is reacting with 27 grams of aluminum. So 35.5 grams of chlorine will react with 9 grams of aluminum. So the equivalent mass of aluminum is 9. Sanjay, in case you have got some other doubt, then it is okay. Otherwise, means you have raised your hand. Kindly see to it. In case you have got some other doubt, please message me. Otherwise, please don't raise your hand. So now here we can see that the amount of a substance that is reacting with 35.5 gram of chlorine. Sodium is 23, calcium is 20, and aluminum is 9. What I taught you in the last class, let us have a look at that. When we were talking about the equivalent mass of an element, here you have got element. As far as element is concerned, for sodium the n factor is 1, for calcium it is 2, for aluminum it is 3. So for sodium the equivalent mass which we calculated was 23. For calcium, it was 20. And for aluminum, it is. So we did it in the last class. And today also we can see that by this concept, the same equivalent mass is coming. For sodium, it is 23. For calcium, it is 20. And for aluminum, it is 9. So what is equivalent mass? Equivalent mass is the mass of a substance that reacts with 35.5 grams of fluid. Same as per this part is concerned. Same goes with oxygen also. I'll give you one example. Say we are talking about aluminum only. Aluminum reacts with oxygen and it gives you Al2O3. In this compound, I can see that 2 into 27 grams of aluminum is reacting with 3 into 16 grams of oxygen. So 3 into 16 gram of oxygen is reacting with this. How many grams of aluminum will react with 8 grams of oxygen? That is 2 into 27 upon 3 into 16 into 8. 8 2 just 16. You cancel out. Then 27 by 3. That is what? 9. 9 is what you are getting again. So what is equivalent mass? Equivalent mass is the mass of a substance that reacts with or displaces 35.5 gram of chlorine, 8 grams of oxygen, or 1 gram of hydrogen. That's what equivalent mass is. Now, let us move on to that question which I gave you in the last class. This is the question which we had in the last class. 10 grams of an unknown metal was reacting with oxygen and it was giving us 14 gram of metal oxide. That means 14 grams of metal oxide contains 10 grams of metal. That is, rest 4 grams is what? Oxygen. According to law of conservation of matter, rest 4 gram is oxygen. So we can say 4 grams of oxygen is reacting with 10 grams of metal. So 8 grams of oxygen will react with 20 grams of metal. 8 grams of oxygen will react with 20 grams of metal, and this is the equivalent mass of the metal. So you need not to have the molar mass, you need not to have the N factor if the concept is clear to you. What is equivalent mass? Equivalent mass is the mass of a substance that reacts with or displaces 8 grams of oxygen, 35.5 grams of chlorine, or 1 gram of hydrogen. If you keep this thing in your mind, most of the questions they'll become very easy for you. Now let us have a look at the same example of KMnO4 and K2Cr2O7. This time you'll not get confused. See, if the molar mass of KMnO4 is M, how many moles of KMnO4 you have got? 2 moles. That means 2 grams of KMnO4 is giving you 5 moles of oxygen. That is 5 into 16 grams of oxygen. So 2 grams of KMnO4 is giving you 5 into 16 grams of oxygen. So how many grams of KMnO4 will give you 8 grams of oxygen? 8 grams of oxygen. That is 2m upon 5 into 16 into 8 to just 16. Cancel it out. You will get m by 5. So m by 5 is the answer which we got in the last class also. In this case, you will not get confused whether you have to write m by 5 or m by 10. You can never get m by 10. As far N factor of an oxidizing or reducing agent is concerned, I told you that in many of the books you will see that it is number of electron gained or lost by oxidizing or reducing agent. But many a time when such question comes, people they get confused whether they have to write m by 5 or m by 10. By this method, you will never get confused. You will always get correct answer. Let us check it for the next equation also. In this case, our answer was m by 6. See how many oxygens we are getting. We are getting 3 oxygen. And how many moles of K2Cr27? 1 mole. And molar mass of K2Cr27 say m. I can say that 3 into 16 grams of oxygen is given by m grams of potassium dichromate, that is K2Cr2O7. then 8 grams of oxygen are given by m by 3 into 16 into 8. So 8 to the 16. So you'll get answer m by 6. And this is the correct answer according to the n factor also. So you'll never get confused whether you have to write m by 6 or m by 12 or m by 10 or m by 9. Always calculate equivalent mass according to its definition. It will take lesser time. It will give you a correct answer. You'll never get confused. So again, equivalent mass is the mass of a substance that reacts with or displaces 1 gram of hydrogen, 35.5 gram of fluorine, or 8 grams of oxygen. Based on this, I'll show you. I'll give you one more question, and we'll calculate equivalent mass. See, this question I saw sometime back in mains paper. A question is like this: you have got, say, 5 grams of a metal oxide. I don't know the molar mass of that metal, and I don't know the end. When it reacts with chlorine, it gave us 8 grams of metal chloride. I don't know the formula of metal chloride also. So 5 grams of a metal oxide on reaction with HCl. If you want to write it down, please write it down. 5 grams of a metal oxide on reaction with HCl gives 8 grams of metal chloride. What is the equivalent mass of the metal? So again, you can see that this type of question, they are not there in the textbooks. NCERT वगैरह में नहीं है बेटा. How to calculate equivalent mass? कैसे calculate करें equivalent mass को? फिर दोबारा से again you have to rely on the definition. जो definition अभी मैंने बताई, you have to rely on that definition. See, I don't know what is the mass of metal in this metal oxide. I will consider that mass X. So the mass of oxygen here is 5 minus X gram. So I will say 5 minus X grams of metal oxide combines with X gram of metal. Therefore, 5 grams of, will correct it, 5 grams of metal oxide. This is metal. 5 minus X gram of oxygen combines with X gram of metal. Again, you have got 5 grams of metal oxide. Suppose the metal in that metal oxide is X, then oxygen is 5 minus X. So 5 minus X gram of oxygen combines with X gram of metal. Therefore, 8 grams of oxygen will combine with X upon 5 minus X into 8 grams of. So this is the equivalent mass of the metal according to this metal oxide. Now this metal oxide has got converted to metal chloride. Now since metal is same, that means the mass of metal will also be same. So here also you have X gram of metal. So in this case, chlorine is 8 minus X. Now we'll calculate the equivalent mass according to chlorine. That is 8 minus X gram of chlorine reacts with X gram of metal. So 35.5 grams of chlorine will react with X upon 8 minus X into 35.5. 35.5 grams of metal. So this is the equivalent mass of the metal according to chlorine. Now equivalent mass of the metal will remain same. What you will do? You will equate these two masses. Right? X upon 5 minus X into 8 equal to X upon 8 minus X into 35. From here, you will calculate the value of X, and you have to put that value of X in any of these formula, either in this one or in this one. Because both of these formula, they represents the equivalent mass of the metal. Again, I am giving you that example. I am explaining you this example again. See, the question we have, you have got 5 grams of metal oxide, which on reaction with HCl will give you 8 grams of metal chloride. What is the equivalent mass of the metal? So in this case, in the first case, we'll consider, let the mass of the metal is X, then the mass of the oxygen is 5 minus X. So if 5 minus X gram of oxygen is combining with X gram of metal, 8 gram of oxygen will combine with this many grams of metal. This is the equivalent mass of the metal according to its oxide. Now, since metal is same, its mass is same metal oxide has got converted to metal chloride. That means the mass of metal will remain same. So in chloride also, the metal is X gram. Hence, chlorine is 8 minus X gram. So here we'll write 8 minus X gram of chlorine will react with X gram of metal. So 35.5 grams of chlorine will react with this many grams of metal. So here you have got equivalent mass of the metal according to the chloride. Now since metal is same, its equivalent mass will also remain same. So you have to equate these two equations. That's what I have done. So here I'm equating these two equations and I'm calculating the value of X. The value of X which you will get is not equivalent mass. You have to put that value in any of these formula because these formula they represents the equivalent mass and you will get the equivalent mass of the metal. You got it or not? In case you got it, please thumbs up. Show me your thumbs up in case you are getting it. In case you want me to repeat it, please raise your hand or write down a message. I'll repeat it. Okay. So this is what we have to do. This is how we can calculate the equivalent mass. Now, based on equivalent mass, we'll add one more term that is not given in NCERT. We'll add it and we'll see some questions based on that. Today we'll see a term, we call it vapor density. Vapor density. If I talk about vapor density is not density, which we cannot say that it is density and it has got a dimension like gram per cubic centimeter. No, it's not that. Then what is vapor density? It is slightly different from density. Vapor density does not have any dimension. We can say vapor density is the ratio of mass of p liters of a gas divided by mass of p liters of hydrogen. So mass of p liters of a gas divided by mass of p liters of hydrogen. Now, what v liters represent? Any volume. Here I am changing this volume to 22.4 liters at STP. So vapor density is the mass of 22.4 liters of a gas at STP divided by mass of 22.4 liters of hydrogen at STP. Dear students, the mass of 22.4 liters of a gas at STP is its molar mass. So what we can say, vapor density is equal to molar mass of a gas or a substance. It can be gas or any substance. Molar mass divided by molar mass of hydrogen. We know the molar mass of hydrogen is 2. So what we can say, vapor density is molar mass. My dear student, you know that mass it is calculated in grams or kilograms. So if you are writing grams in the numerator and in the denominator also you are writing 2 grams, they'll get cancelled out. So we say 2 into vapor density is always equal to molar mass. So it is dimensionless. So what is vapor density? We can say vapor density is half of molar mass, or 2 into vapor density is molar mass of the substance. Now we can calculate molar mass of the substance. Now, based on this vapor density and equivalent mass, which we have learned, we'll do some questions based on that. Okay. Here I'm giving you a question. In that question, I've got vapor density. The vapor density of a metal chloride, I don't know the formula of the metal chloride, is 66. The vapor density of a metal chloride is 66. Its oxide contains 53% of metal. What is the atomic mass of the metal? We have to calculate atomic mass of, again, so again, you have got vapor density of metal chloride and you have got metal oxide which contains 53% of metal. You have to calculate atomic mass. Here, student, kindly see, this is known as volatile chloride method of calculating atomic mass. I gave you one question and I'll explain that concept by this question. Such questions, they are not in textbook. Again, our book has got a lot of questions like this. I'm talking about this. So if you are, means the link which I'm sharing, these links, they are going to help you a big way. You will get to know the important topics of different chapters. You will get to know the important chapters itself. So JEE Main's weightage, topic-wise weightage, high-scoring topics, and 10 years questions with solutions. So there also you'll see such questions. Okay, ji. I have to calculate the atomic mass. I don't know the formula of the metal chloride. Let the formula of the metal chloride is MClX. So you have to pay attention toward this thing. The formula of the metal chloride will always be MClX, where X is the valency of the metal, and we know that the valency of chlorine is always 1. So if you cross multiply it, you'll always write M, whereas as far Cl is concerned, Cl is X, depending on the valency of the metal. So I can say molar mass of metal chloride is equal to molar mass of metal plus X into molar mass of chlorine, that is 35.5. Okay, let's move ahead. As per molar mass of metal chloride is concerned, that I can calculate from here. This is the vapor density. So 2 into 66 will give me the molar mass. That is 132. So 132 is the molar mass of the metal chloride, which I am getting from vapor density. 2 into vapor density will give me molar mass. So that is equal to molar mass of metal chloride. That is equal to molar mass of the metal. Now, where from I will get molar mass of the metal? This metal oxide is going to help me in that. From here, I will calculate the equivalent mass. See, this metal oxide has got 53% of metal. That means 47 grams is oxygen. I can say 47 grams of oxygen is combining with 53 grams of metal. Therefore, 8 grams of oxygen will combine with 53 by 47 into 8. (53) divided by 47, 8. That is 9. So its equivalent mass is 9. Please pay attention. Equivalent mass is 9. We know that molar mass upon X, that is valency, is equivalent mass. Here in this case, the equivalent mass is 9. So 9 into X is molar mass. So in place of molar mass, I can write 9X plus 35.5X is equal to 132. That is 44. 132 is equal to 44.5X. So X is equal to 132 divided by 44.5. That is 2.96. We can round it off. So X is 3. Here in this case, X is 3. And equivalent mass we already know, that is 9. So what is molar mass? That is, this is the molar mass of the metal. I'm again repeating this question. I've been given a metal chloride whose vapor density is 66. And I have been given a data of its metal oxide. And it is told that this metal oxide contains 53% of metal. That is 47 grams. 47 grams is what? Oxygen. Now calculate the molar mass of the metal. This method is used to calculate molar mass of metals and it is known as volatile chloride method. So we can say the molar mass of metal chloride is equal to molar mass of metal plus the mass of chlorine. That is its molar mass into X, where X is the valency of the metal. Now in this case, metal oxide, it has 53 grams of metal. That is 47 grams of oxygen. So 8 grams of oxygen will combine with 9 grams of metal. This is the equivalent mass. So molar in place of molar mass, I can write equivalent mass into valency of the metal is equal to 35.5 into valency of the metal. From here, I'll calculate valency of the metal. That we get 3. So 3 into 9, that is 27 is the molar mass of the metal. So this is how you can calculate molar mass of a substance by volatile chloride method. We saw volatile chloride method. Now comes law of equivalence. If you learn this law, most of the reactions will become easier for you. What does law of equivalence means? My dear student, you might have seen that X mole of a substance reacts with Y moles of another substance. Why it happens? Why X mole react with Y moles? Say I've got HCl. I will say 1 mole of HCl will react with 1 mole of NaOH. Sorry, NaOH. 1 mole of HCl will react with 1 mole of NaOH. Likewise, 1 mole of H2SO4 will react with 2 moles of NaOH. Why 1 mole of HCl is reacting? Just a minute. Why 1 mole of HCl is reacting with 1 mole of NaOH and why 1 mole of H2SO4 is reacting with 2 moles of NaOH. Likewise, 1 mole, 2 moles of HCl is reacting with 1 mole of calcium hydroxide. Whereas 1 mole of sulfuric acid reacts with 1 mole of calcium hydroxide. Why it is so? See, all these reactions, they move according to law of equivalence. What is law of equivalence? Law of equivalence states that the equivalent mass of one of the substance will always react with the equivalent mass of another substance. Now, since equivalent mass is not given in the textbook of CBSE, that's why many times students they face problem when they go for competition. There they see question based on equivalent mass. So according to law of equivalence, I'll give you example for that also, and I'll give you such examples which you have already done in your school, but you have not read them according to law of equivalence. So according to law of equivalence, the equivalent mass of one of the substance always reacts with the equivalent mass of another substance. Let us have a look at the first equation. We know the molar mass of NaOH is 40 and its n factor is 1. So its equivalent mass is 40. Likewise, the molar mass of HCl is 36.5. Its n factor again is 1. So its equivalent mass is 36.5. That is 40 grams of NaOH is reacting with 36.5 gram of HCl. That is equivalent mass of NaOH is reacting with the equivalent mass of HCl. Likewise, if I move ahead, let's talk about sulfuric acid. Here I can see that 2 into 40 grams of NaOH is reacting with 98 grams of sulfuric acid. That is 40 grams of NaOH will react with 49 grams of sulfuric acid. Now this is the equivalent mass of sulfuric acid. Equivalent mass is 98 by 2. So that is 49. So from here also it is clear that equivalent mass of one of the substance will always react with the equivalent mass of another substance. Now, if I talk about HCl, see, 2 into 36.5 grams of HCl is reacting with molar mass. Well, I'm not writing molar mass. I'm explaining without that. With molar mass of calcium hydroxide. 2 into 36.5 gram of HCl is reacting with molar mass of calcium hydroxide. We know the equivalent mass of HCl is 36.5. So that will react with m by 2 grams of calcium hydroxide. Now this m by 2 is equivalent mass of calcium hydroxide because n factor of calcium hydroxide is 2. It donates 2 OH negative. That's why its n factor is 2. So from here it is clear that equivalent mass of one of the substance always reacts with equivalent mass of another substance. Based on that, I give you one question. See, there is a question. One gram of hydrogen combines with 80 grams of bromine. Now we have an unknown metal. So 1 gram of unknown metal combines with 4 grams of what is the equivalent mass of that unknown metal. See, dear student, no molar mass is given. In the last class was based on molar mass, n factor, everything like that. And question based on that also comes. But here in today's class, I am not dealing with molar mass, I am not dealing with n factor. I'm simply telling you how to calculate equivalent mass without molar mass and n factor. So 1 gram of hydrogen combines with 80 grams of bromine and 1 gram of an unknown metal combines with 4 grams of bromine. What is the equivalent mass of this unknown metal? How to do it? See, if 80 grams of bromine is reacting with 1 gram of hydrogen, that means this 80 gram is what? Equivalent mass. This is the equivalent mass of bromine. 1 gram of hydrogen is combining with 80 grams of bromine, and I have already taught you this. What is equivalent mass? Equivalent mass is the mass of a substance that reacts with or displaces 1 gram of hydrogen or 35.5 gram of chlorine or 8 grams of oxygen. Now 80 grams of bromine is reacting with 1 gram of hydrogen. So this is the equivalent mass of bromine. Now let's move further. 4 grams of bromine reacts with 1 gram of metal. So 80 grams of bromine is going to react with 1 by 4 into 80 grams of metal. That is what? So in this case, you can easily calculate at 20. So here the equivalent mass of the metal is 20 grams. It is very easy to predict. This is calcium. Because calcium has got a molar mass 40 and its N factor is 2. 40 divided by 2. This is what I taught you many a times. That 40 by 2, that is 20. So 20 is the equivalent mass of calcium. So here we are talking about calcium. See, this question is based on law of equivalence. The equivalent mass of one of the substance will always react with the equivalent mass of another substance. From the first equation, we came to know that equivalent mass of bromine is 80. Now this 80 grams of bromine is going to react with how many grams of that unknown metal? 20. So this 20 is the equivalent mass of that unknown metal. So this is how we can calculate equivalent mass according to law of equivalence. This law of equivalence is also used in practicals of 12th standard and 11th standard. I give you one example for that. Say I am talking about a titration between KMnO4 and oxalic acid. When we perform this titration between KMnO4 and oxalic acid, we maintain slightly acidic pH. We have already done this equation, KMnO4 equation. This is what we did in the last class, last topic of the last class. This equation I'm talking about. KMnO4 plus sulfuric acid will give you K2SO4 plus MnSO4 plus 3H2O plus 5 oxygen. So here again I'm writing KMnO4 plus H2SO4 will give you K2SO4 plus MnSO4 plus H2O plus 5 oxygen. Let's do balancing of this. So 2 and 1, 3. This is the balanced equation. So KMnO4 is an oxidizing agent that is donating oxygen. And it is, suppose it is oxidizing oxalic acid. So oxalic acid is what? COOH. This is oxalic acid. So it will gain oxygen from air and will get converted to CO2 plus H2. I can see that one more, or I can see that as far this equation is concerned, it is donating 5 moles of oxygen, and this equation, it is gaining 1 oxygen. So it has to be multiplied by that oxygen will get balanced. Okay, Ji. When we calculate molarity, we use formula. See, we use formula M1V1 is equal to M2V2. A lot of students, they know this. M1V1 is equal to M2V2. But here I want to inform you one thing, that there is no such formula. And no, it's never like that. M1V1 is equal to M2. There's no such formula. The formula is actually N1V1 is equal to N2V2. This is the formula. Now we know that as far normality is concerned, it is N factor into molarity. So we'll write N factor into M1V1 is equal to N factor into M2V2. If you have got a same compound on both the sides of of this RHS or LHS, if you got a same compound, then its N factor is same. That means N1 is equal to N. This N1 is equal to N2. In that case, it gets cancelled out and the formula becomes M1V1 equal to M2. So generally we use that formula M1V1 equal to M2V2, whereas the actual formula is N1V1 is equal to N2V2. Now we had to apply this formula to the above equation, to this equation. When we carry out titration, we generally write 5 into M1V1 is equal to 2 into M2V2. Many times students, they ask their teacher, sir, which side will put this 5? Towards oxalic acid or towards KMnO4? They get confused. What we have to do? Because if you balance this, you will have 5 moles of oxalic acid that combines with 5 moles of oxygen to give you 10 moles of CO2 and 5 moles of H2. This is what it will give. Many a time they get confused where to write 5 and where to write 2. But now it will become clear that these 5 and 2, this 5 and 2, it represents N factor. Students, they generally see that oxalic acid, we have got 5 moles of oxalic acid that is combining with 2 moles of KMnO4. So towards 5, they generally write oxalic acid, which is wrong. Will not write oxalic acid. Towards 2, they generally write KMnO4. That again is wrong. Although the moles are 2, but this 2 does not represent number of moles. As far as this 2 is concerned, it represents the N factor. So oxalic acid, you know, the N factor of oxalic acid is 2. I taught you in the last class. So towards 2, where 2 is written, this is oxalic acid, N factor of oxalic acid. And as far KMnO4 is concerned, we have already done it twice. That its N factor here is 5. So here you write 5 for KMnO4. So the actual formula is N1V1 is equal to N2V2. Based on this formula, I'll extend this formula a bit more. Many a time it comes like you have got 0.1 molar HCl and you are combining it with 0.2 molar HCl. You are combining 0.1 molar HCl and you got say 10 milliliters of it. And you are combining it with 0.2 molar HCl and say its volume is again 10 milliliters. What is the molarity of the resulting solution? So here the formula will be, again, it is N1V1 plus N2V2 is equal to N3V2. But since we have got HCl, that means the N factor is same. We have got a same compound, so N factor is same. So this formula get reduced to M1V1 is equal to M1V1 plus M2V2 equal to M3V2. That is 0.1 molar into 10 because its volume is 10 milliliter plus 0.2 molar, again its volume is 10 is equal to M3 and here the volume is 20. 10 plus 10. Many times you will see that instead of V3 it is written V1 plus V2. So sometimes it happens that the volume is not given, so you write V3 is equal to V1 plus V2, and sometimes it happens that the volume is given. Like 10 milliliters of 0.1 molar HCl combines with 10 milliliters of 0.2 molar HCl. The volume of the resulting solution is made 1 liter by adding water. What is the molarity of the resulting solution? So in that case, V3 will become 1000. But here, since we are not adding water, so the volume is V1 plus V2. This is how you will calculate molarity. So by now, a quick recap. We have done what is molarity. We have done what is normality. We did what is equivalent mass. We did what are N factors. We did what is equivalent mass without N factor. We did questions based on that. After that, we did law of equivalence. After law of equivalence, we did some of the questions based on that. After that, I'll explain a small concept that is to calculate the molar mass. And it is through specific heat. We call it Coulomb's and Petit's law. Coulomb's and Petit's law. According to this rule, the molar mass of a substance is nearly equal to 6.4 by Gates specified. So as far this law is concerned, it gives us a bit relation between atomic mass and specific heat. So many a time question it comes like the specific heat of an unknown metal is this. What is its molar mass? Nothing like this is given in the in CBSE textbook. So you have to remember this formula. This is the relation between molar mass and specific heat. This is how you can calculate. So as far some basic concepts of chemistry is concerned, or what we call mole concept, the important topic is normality and equivalent mass and factors, calculation of equivalent mass, law of equivalence. And as far as stoichiometry is concerned, where you balance equations, in competitions, they are not there because they are very basic. What we are doing that part which is there in the competition, and it is not given in NCERT. We have to do it. You will see one more term. I've done, means we did percent by mass, we did strength, we did molarity. I'll talk about molarity also. Molarity is represented by small m. Normality is over, equivalent mass is over. Molarity is represented by small m. It is the number of moles of a solute that are present in every 1 kilogram of solute. Its dimension is mole per kilogram. And molarity is a better concentration expression as compared to molarity. See, molarity is represented by capital M, and that is mole per liter. But since it is depending on volume, and volume changes with temperature, so molarity keeps on changing with change in temperature. On the other hand, molarity depends on mass, kilogram, mass of solvent. That does not changes with change in temperature. So molarity does not changes. So molarity does not changes with change in. There is one more concentration which is used in a lot of chapters like equilibrium, like thermodynamics, solutions. We call it mole fraction. Mole fraction. It is represented by symbol chi. Now suppose I have got a solution which is made up of solute and solvent. As I told you, solute we always represent by B and solvent by A. Suppose the number of moles of solute is B, and that of solvent are Na. So mole fraction of solute is number of mole of solute upon number of mole of solute plus number of mole of solvent. Likewise, mole fraction of solvent is number of mole of solvent upon number of mole of solvent plus number of moles of. Here you can see since denominator is larger than numerator, that's why the value of mole fraction of both the components is always lesser than 1. And you have to remember chi A plus chi B is always equal to 1. So mole fraction of a component is always lesser than 1. The sum of mole fraction of all the components is always equal to 1. And whenever a component, one more thing, whenever a component is in the pure state, its mole fraction is always 1. Because if B is in the pure state, there is no A. So NB by NB is 1. Again, the mole fraction of a component is lesser than 1. The sum of mole fraction of all the components is always equal to 1. The mole fraction of a component in its pure state is always equal. So these are some of the concentration expressions which you have to keep in your mind, because they are very much used in physical chemistry. We'll be using normality, equivalent mass. We will talk about equilibrium or thermodynamics or a bit of gas state. That we'll use it. In today's class, this is all what we were supposed to do. Kindly revise it. In case you have got any doubt, please come up with your doubt. I've already shared link with you. You can send your doubt to that link, or you can message us. In the next class, when you come, you can directly message me in the chat. I'll see that and I'll solve your doubt. That's all.